Hello, so today in this video we're going to be covering chapter 3.1.2, which is polynomial functions and their graphs. Let's hop right into it. Now, some things that we want to know when we're learning about polynomial functions and their graphs is a few terms. So there's even and odd functions. Even functions will have so we're talking about end behavior with polynomials. Even functions will have both of their ends pointing in the same direction. So either up and up or down and down, like a smiley face or a frowny face. Odd functions, let me just erase this. Odd functions will have basically the opposite. Down to up or up to down. Now, one thing to note is even functions, when they are positive, will go up and up. Odd functions, when they are positive, will go down to up. And then even functions, when they're negative, will go down to down. And odd functions will go up to down. So basically like a normal line. So we have even for this. And then, positive for up and down. And then negative. Basically like a linear slope. A linear slope is an odd function. You'll also know if it's an even function. If the degree of the function is like an even number. So for instance, if you have something like x squared plus x, plus x plus 3, this is going to be an even function because the degree of the polynomial, and if you don't remember what the degree of a polynomial is, I recommend checking out my last video that I just uploaded, 1015 chapter 3.1.1 polynomials. This is an even polynomial because the degree of it is an even number. The degree of the polynomial, it's a second degree polynomial. And so it's an even function. Now, if it was an odd function, it'd be like x cubed plus like x squared plus like 3 or something like that. This would be an odd because it is an odd number for the degree. Now, the end behavior, when we're talking about negative or positive, if it's a positive, if our leading coefficient is a positive number, and in this case it is, then for the even function, it'll be up and up. And then for our odd number, it'll be down to up. Now, if it was negative, then it would be down to down for our even. And up to down if we're reading left to right for our odd function. Now, so that covers even and odd. And we learned, and then another thing, when we're talking about functions, it can have as many turning points as the degree of our polynomial minus 1. So degree minus 1. So for instance, this one can have up to 2 turning points, and so it'll look like this. A turning point is basically where you have like a max and a min, where it turns from going positive to negative or negative to positive. So this can have 2 because its degree is 3. If it was like x to the 14th, it could have 13 turning points. And with that knowledge, you can determine what degree your function is due to how many turns you'll have. Let me see if there's anything else I need to mention. I believe that covers it. So we'll just go into some of the examples from Lumen. This one is asking us to determine the degree of the polynomial function graphed below. Oh, one thing to mention, zeros of a function is where it hits on the x-intercept, basically the solution. When y equals 0. So, the degree of this polynomial function is the third degree because it has 2 turning points. This one is an odd function because we have the ends pointing down and then going up. So they're not in the same direction. This one is even because we have both of them pointing up. This one is even because we have both of them pointing up. This one is odd because we have both of them different directions in starting and end points. This one is even because they both are pointing up. This one is even because they both are pointing up. and this one is odd because it's going down to up. Now, this one says, for the following graph of a polynomial, is this even or odd? This one is odd because it has one going up and one going down. Is it a negative or a positive leading term? And it's going to be negative because we start going up and then we go down. This one is asking us to find the degree of the function and whether it is negative or positive leading term. So this one is an odd one because we have up and down. And it's negative because we start tall and end low. This one is odd because it has two different directions, and it's positive because we start low and high. This one is even, and it's negative because we start low, end low. Yeah. Now, use the graph of the polynomial function to identify the zeros of the function. Now, for this one, we basically want to see what the x-intercepts are. And with your examples, they won't be so pixely, and you can also click this magnifying glass to make things a bit bigger. Now, the zeros of this function is going to be -1, 0, and 3. Here's a 3, here's a 0, here's a -1. You want them in, I believe you want them in descending order. Well, like ascending order, so smallest to biggest. This one's telling us to use the graph of the polynomial function. Basically, same question, to identify the zeros. This one is a bit harder to see on here, but it's basically going to be 1 and then 5. This one is asking us how many turning points are on this graph of x to the 4th minus y x squared, and it's going to be 3. So we have one right here, one right here, and one right here. And what is the maximum number of turning points we can have? And that's going to be 3 because it's going to be the leading term's degree. So 4 minus 1, which is 3. Yeah, if you have any questions, please let me know, and I'll answer as soon as I can. Have a good one.